Okay, so here's chapter 13 in the textbook. We're going to look behind the scenes how the internet works. This is our last chapter in the textbook. We've already talked about the internet in my lectures, my presentation of the material, but I think it's nice to also go through the textbook and just kind of speak to what you're learning this week in the textbook. Describe the management of the internet. So the internet has different governing bodies, but it's not owned or controlled by anybody, but there's people who make recommendations about the standards of the internet, and that's kind of the way the internet's managed. And you could companies have representatives on those organizations that make recommendations about the standard of the internet, but the internet also grows and evolves on its own, just based upon what people build and what they contribute and what the world does, which includes every single person in it. Explain how the internet's, so nobody owns the internet. Though soon that might change because Elon Musk is creating Starlink, and he will own the internet when this is operational. And so the internet, this is a good distinction to make. The internet is, it's amazing. The internet, there's the internet, which is all the hardware. It's the cables, it's the wires, it's the satellites. And then there's the World Wide Web, which is email and websites and apps. A lot use the TCP/IP standard. And so all that runs as software. The World Wide Web runs as software on top of the hardware, which is the internet. And so there's been many iterations of the web. And the web's gone through evolutionary stages of, like that are distinct. And you could say, okay, that was like that stage of the web, and here's this Web 2.0. And the internet's always just been the internet. And so the internet is now finally going through its own evolution to what I think of as Internet 2.0. And that's going to be Starlink. So Elon Musk's going to surround the planet in low orbit satellites. And everybody on the planet will have access to like gigabit internet anywhere on the planet. And so that's going to be a game changer. And he's basically going to own the hardware of the internet. And everybody who gets on the internet will have to will be going through Elon Musk's Starlink. That's pretty amazing. So watch that. Explain how the internet's networking components interact. So there's routers and satellites and cables, and things get broken up into packets and get dropped onto the network, and then routers help those packets of information find their destination, then they get reassembled. So that's email and voice and video, and everything gets broken up into packets like that. List and describe the internet protocols used for data transmission. So we'll see what they list there. Explain how each device connected to the internet is assigned a unique address. So every device connected to the internet is given a unique address, IP address, and discuss how numeric IP addresses changed into readable names. So we have domain name servers. And we can, just like, on your phone, everybody you want to call has a phone number, but you don't type in the number. You just kind of click on their picture or their name, and then the number gets dialed. Same thing with the internet. You don't enter the IP address, the equivalent of the phone number. You just enter the name of the website, and then like the phone number gets dialed for you. The IP address, you get taken to that IP address. And the technology that knows how to connect the domain name, the website name, with the IP address is known as a domain name server. And so your request for a certain domain, www.cnn.com or fox.com, just to be nonpartisan, right? When you enter that, it goes to a DNS server, domain name server, figures out what the IP address is, and gets you the information in that IP address. So that's how that works. Compare and contrast a variety of web development languages. We've kind of talked about that. HTML and CSS and JavaScript build the front end. And then the back end is going to be databases and some programming language. I recommend Go. There's also other options like, PHP or Ruby. But Go is the best. Compare and contrast server-side and client-side application software. So, and discuss the mechanism for communicating via email and instant messaging, explain how data encryption improves security. So let's thumb through these pretty quickly here. Internet society provides leadership, internet management and networking management. Internet society provides leadership for orderly growth and development of the internet. So that's the Internet Society. Internet Engineering Task Force researches new internet technologies. Internet Architecture Board provides direction for the maintenance development of internet protocols. Internet Corporation of Assigned Names and Numbers is responsible for managing the internet's domain name system and allocation of IP addresses. And World Wide Web Consortium is sets standards and develops protocols for the web. So those are all kind of like the management and networking bodies of the internet and the World Wide Web. Just different organizations that, you know, help sort of guide the technology. But nobody makes laws, and nobody, you know, nobody ultimately, in theory, owns the internet. That said, if you violate things, your stuff might not work with all the other technology that everybody's building technology to these standards, or you might just get blacklisted and nobody will ever find your stuff because you're janky and the search engines will never rank you. So, internet is a network of networks. There's backbones in the internet. So backbone is like the main pathways of the internet with the big kind of fiber optic cables that carry all the data. And so you can kind of see a map of the backbones there. The main paths of the internet, data travels fastest on these fiber optic backbones. Collection of large national and international networks, optical carrier line, fiber optic. Internet exchange point is used for connecting internet service providers, one or more network switches. Point of presence, used for individuals, bank of modems, servers, routers, and switches. Client server model is used for the internet, common internet servers, web server, commerce server, file server. Network follows standard protocols to send information. A protocol is a set of rules for exchanging electronic information. They are the rules of the road, as open as opposed to proprietary. I think we talked about protocols when we talked about networking. So protocols, just like it's rules that need to be followed for sending information. We have communication protocols, right? When we talk in person, we listen when somebody else is talking. We look at them. We don't burp, right? If we do, we say, excuse me. Like, these are our protocols for communication. And computers have protocols for communication too. So circuit switching versus packet switching. Right? We talked about circuit switching. That's the old way of doing it. And you can see it's inefficient when applied to computers. Computers transmit data in a group or burst. Processor works on the next task and ceases to communicate until ready to transmit next burst, so it's stupid to maintain an open connection. And circuit would have to remain open. Packets breaks data into chunks called packets and sends them over various routes to destinations. So the routers find the destination. The packet contains the address to which the packet is being sent, address from where the packet originates, reassembly instructions, and data that's being transmitted. So TCP/IP is the main suite of internet protocols, consists of many interrelated protocols, transmission control protocol, and then also internet protocols responsible for sending the information from one computer to another. Each internet device is required to have an IP address, right? It's the internet protocol address. Internet Corporation for Assigned Names and Numbers, ICANN, ensures IP addresses are unique. IP addresses forms dotted decimal, dotted quad octet. So they look like, 24.116.82.49 or something like that, right? Internet Protocol version 4 is created in 1981, over 4 billion possible values for IP addresses. Internet Things Explosive Growth and Internet-Enabled Devices. Internet Protocol version 6 provides more IP addresses. How a computer gets an IP address. There's static, there's dynamic. And static IP addresses never change, assigned by network administrator or internet service provider. Dynamic is IP address is temporary, it's assigned from a pool of addresses, and that's more common. Top level domain is like .com or .org. And second level domain is unique within its own TLD, top level domain, and not necessarily unique to all top level domains. So we have .com as a top level domain. And then, I don't know, what's Starlink.com. Starlink is the second level domain. and .com is the top level domain, just kind of some of the things. So computer converts URL to an IP address, domain name system server, functions like an internet phone book. So I already told you about this, and you could pause the video and look at that graphic if you'd like. HTML is the web technologies. It's not a programming language. We kind of talked about markup language and looked at how to write a little page of HTML. This is what Tim Berners-Lee invented. And so you can see there the bold, the B and the I is going to bold and italicize anything between it. You can see the opening tags and the closing tags, but that's the HTML markup language. And then CSS does the formatting. So it says what color text should be and how it should be formatted. So that's CSS. XML is kind of old, and it's a way to transfer data between machines. The new, better way is JSON, which stands for JavaScript Object Notation. That's like, so sometimes computers, if it's not meant for humans, right? If you just need to transfer data from one machine to another, we'll put it into JSON. There's the hypertext transfer protocol, transfers hypertext documents across the internet, and then hypertext transfer protocol secure is used to securely send data over the web through secure socket layers. The old version, or TLS, is the new version. Server-side applications, the web is a client-server network. Program on server is considered server-side, can require many communication sessions between client and server, can perform very complex operations. Yeah, so the code that you write on the server is like that. That's the server-side application. And when you program something on the server, it's considered server-side. There's also the client. So that'd be considered client-side programming, where like the JavaScript is checking to make sure your passwords match before you submit a form. And then when you send it to the server might run some checks on what you've submitted to make sure everything's accurate. So client-side applications are programs that run on the client computer. And client-side apps, primarily focus on operating on the client as opposed to on the server. So JavaScript is client-side scripting language. Applets are old and you don't need to know about them. Email is one of the most common communication methods today. We have the Simple Mail Transfer Protocol, SMTP. It's responsible for sending email. We also have multi-purpose internet mail extensions, which allows sending of files, MIME-type files. And then we have instant messaging is another common communication method. Texting it's kind of like IM. And chatting takes place between two devices through the internet. And encryption. So email, we encrypt stuff so that it can't be intercepted in transit. And we'll talk more about encryption in one of my lectures coming up. And so here's an example of basic rotation encryption. So this might be like ROT13. So the word computer would translate to EQORWVGT, because if you look at C, that's E. That translates to E. If you look at O, that translates to Q, right? And so if you have this key over on the left there, which is this stuff right here, this is the key, then you could figure out this by looking at E is actually, right, goes back to C. Q goes back to O, right? And you could kind of back out the encryption if you have the key. Public key encryption. So, two key encryption, key pair. So the way encryption can work is like, I have a public key and I have a private key. So how do we encrypt stuff with, how do we create an encryption that's secure with everybody? And so I give everybody in the world a key to encrypt stuff with. And so that key might be this, right? I give this to everybody. So that's my public key. And I say, you want to send something to me, you can encrypt it with this. And then when they send it to me, only I can unencrypt it. Okay, only I can unencrypt it, and so people can send anything to me that's encrypted, and nobody else can read it. And then I unencrypt it, and I can read it. And what they'll send me is they will send me their own key, and then with that key, I have the key, and they have the key, and now we can communicate, and nobody else can read it. Right? So there's one-way encryption, where people can encrypt and send to me, but nobody else can read it. And then once that happens, somebody could send me a key, and then we can go back and forth between ourselves because they sent me a key and nobody was able to intercept that key. They have it, I have it, and now we could communicate with encryption. But to establish that, somebody has to encrypt the key and send it to me. So I have a way, I provide a public key that people can encrypt things with. And then this is all programming, by the way. You don't do this as a normal person. Use programs that do this. But I send them, they send me a key that's encrypted. Only I can unencrypt it and see it. And now we both have that key and we could communicate. Nobody else in the world has that key. So that's how that occurs on the back end with encryption. So that's a little bit of chapter 13 about how the internet works. This is week 13. This is our last chapter in the textbook. I will see you next week, chapter 14. Super glad you're here. See you next week.